Hey everyone, and welcome back. We're diving deep today. We'll be looking at a guide all about productivity, especially if you're, in engineering.
Oh, cool.
Yeah, it's about building these daily and weekly habits that can make a big difference. And it's by Louis Mata.
Okay.
And one of the things that I thought was really interesting is this whole idea that like simplicity and consistency,
Mm.
those are really the keys to being more efficient and even like driving innovation.
Yeah, it's funny. In engineering, we're always surrounded by complexity, new
Mhm.
technologies and these intricate problems we got to solve.
Right.
But Mada's guide, it kind of brings us back to the fundamentals, those consistent things we do every day that really set us up for success.
Yeah.
It's a good reminder that, sometimes the simplest things can be the most powerful.
Absolutely, yeah. I think that's true in a lot of areas of life, not just engineering.
Totally.
Um, so let's jump into these daily habits that Mata outlines.
Mhm.
The first one, he starts with something I'm sure a lot of you are familiar with, the morning scrum meeting. That quick stand-up to sync up, figure out if there are any roadblocks,
Yeah.
and make sure everyone's on the same page.
Right, yeah.
But I'm curious, what are your thoughts on why this is so effective, especially for engineering teams?
Well, I think it's all about starting the day with intention and alignment, right? Like, think of the morning scrum as a kind of like a mini diagnostic for your team.
Okay.
You're not just checking in on tasks, you're figuring out if there are any potential issues early on, making sure everybody knows their role in the bigger picture,
Yeah.
and fostering a sense of shared purpose from the very beginning.
Yeah.
And that really sets the stage for a much more focused and productive day.
Yeah, like that saying, well, begun is half done, or something like that.
Exactly.
Getting everybody on the same page first thing can really set the tone for the day.
Definitely.
Okay, so Mata's next daily habit is deep work.
Okay.
This is about making time for those uninterrupted coding hours.
Yes.
No distractions, just pure focus on the task at hand.
I love that. And that's where the magic of flow state comes in, right?
Uh,
You've probably felt this yourself, that feeling of being totally absorbed in your work.
Mm-hmm.
Time just flies by and you're just so incredibly productive.
Yeah.
Deep work is all about creating the conditions for flow state.
Okay.
And I think for engineers, this can be super impactful.
So tell me more about this flow state. How does it specifically benefit engineers, and are there any practical tips for achieving it?
Yeah, for engineers, flow state is like unlocking a superpower, seriously.
Okay.
When you're in flow, you can solve these complex problems way more efficiently. You write cleaner code. You come up with more innovative solutions.
Wow.
It's really about reaching this level of deep focus where your brain is just firing on all cylinders.
That makes sense, and I bet it leads to a sense of satisfaction and accomplishment too, right?
Absolutely.
So how can engineers, set themselves up for success with deep work and tap into this flow state more often?
One of the biggest things is eliminating distractions.
Okay.
So silence those notifications, put your phone on Do Not Disturb, maybe even find a quiet workspace where you can really, really concentrate.
Yeah.
Another technique that I find helpful is time boxing. So dedicating blocks of time specifically to focused coding
Okay.
and stick to that schedule as much as possible.
Yeah, that sounds good.
Yeah.
So we've got a focused start to the day with the Scrum. We've got the deep work sessions to really get things done. What about wrapping up the day?
Yeah.
Mata suggests an end-of-day wrap-up.
This is really important, I think. The end of day wrap up is all about reflection and closure. Just taking a few minutes to kind of document what you achieved that day,
Okay.
identify any challenges that are still there, and set your intentions for the next day.
Okay.
This little habit can help you foster a sense of progress, stay organized,
Yeah.
and avoid that feeling of, wait, what did I even do today?
Oh, yeah.
Which I think we've all felt at some point.
Definitely. So those are the daily habits. Mata highlights morning Scrum, deep work, end-of-day wrap-up.
Yep.
A solid framework for starting strong, staying focused, ending each day with intention.
I like it.
But he doesn't stop there. He also talks about some weekly habits that can really boost team productivity and effectiveness.
I was going to say, what about the weekly stuff?
Yeah.
This is where it gets really interesting.
Okay.
These weekly practices are like the glue that holds everything together.
Oh, okay.
They build a healthy team dynamic, they encourage knowledge sharing, and create a culture of continuous improvement.
Yeah.
They're really all about building a foundation for sustainable success.
That sounds like a recipe for a really good engineering team.
It is.
So let's start with the first weekly habit he recommends, the weekly planning meeting.
Okay. It's all about setting that compass for the week ahead. for your team.
Okay.
Coming together, defining goals, mapping out those deliverables, and making sure everyone's clear on the priorities.
So crucial in engineering, right, where things
Yeah.
get complex.
Oh, absolutely.
Lots of moving parts.
Exactly. Think of a software project, right? You've got your designers working on the UI, you've got back-end developers building the whole infrastructure, and QA making sure it all works seamlessly.
Right.
A weekly planning meeting keeps everyone rowing in the same direction,
Okay.
anticipating any roadblocks.
Yeah, it's like a roadmap for the week,
Exactly.
making sure everyone knows where they're going and has what they need to get there.
I like that analogy.
So dedicated peer feedback sessions, that's the next habit.
Okay.
What's Mada's thinking there?
This one's all about fostering that, culture of continuous learning and improvement.
Right.
It's about creating that safe space for team members to give constructive feedback
Okay.
on each other's work, even their collaboration style.
Yeah, I've heard about feedback, but why are these structured sessions so valuable?
Well, you got to think about it. Engineers are constantly solving those tough problems,
Yeah.
writing complex code, collaborating on these multifaceted projects, Regular feedback helps them see their blind spots, learn from each other, and ultimately just improve the quality of their work.
It's not just about pointing out mistakes then.
No, it's about that collaborative environment
Right.
where everyone can learn and grow together.
Got it. Okay.
Yeah. When done well, these pure feedback sessions can be really empowering.
Okay.
They can help engineers build stronger relationships, improve those technical skills,
Cool.
and become more effective team members.
Yeah, it's about turning feedback into a good thing.
Exactly. Something positive, not something to be scared of.
Makes sense.
Yeah,
So leveraging that collective knowledge and experience then? Right.
exactly.
Okay, on to the final weekly habit, the retrospective meeting.
This is a good one. This is where you kind of hit the pause button at the end of the week.
Okay.
Reflect, What went well? What could be better? How do we optimize for the future?
Right.
It's dedicated time for the team to analyze, celebrate wins, identify areas for growth.
So it's not just a pat on the back session.
No, it's also about embracing those challenges, seeing them as opportunities for growth.
Got it. Make sure those lessons stick.
Yeah.
So beyond these habits, Mada dives into something else pretty crucial, the power of reasoning.
He's spot on there. Reasoning is at the heart of what engineers do.
Okay.
From problem solving to debugging, designing complex systems, making those critical decisions.
So it's not just the technical skills,
No.
it's about how you think.
Precisely, and Mata breaks this whole reasoning process down into 8 stages. Might seem a bit much at first,
Okay.
but it's really a clear framework.
All right, I'm interested. Break it down for me, starting with perception.
All right, so imagine you're an engineer, you've got this bug in the code
Yeah.
causing some weird behavior, right? Perception is all about gathering information.
Okay.
Error messages, logs, user reports, anything that sheds light on the issue.
So like putting together a puzzle, you need all the pieces.
Exactly. Every detail matters.
Okay, so you're being thorough like a detective,
Exactly.
gathering clues.
Right.
All right, what's next?
So once you've got enough info, you move to understanding.
Okay.
This is where you analyze the data, you start to see those patterns,
Okay.
try to make sense of what you've observed.
You're not just seeing it, you're comprehending it.
Right, you're looking for those aha moments where it all starts to click.
Got it.
You might notice the bug only happens under certain conditions.
Okay.
Or maybe it's always triggered by a specific sequence of events.
Right. Narrows it down then.
Exactly. Helps you get closer to that solution.
Observed, understood. What's next?
Next comes hypothesis. This is where you come up with a possible explanation for the problem
Okay.
based on what you understand so far.
An educated guess.
Yeah, like, okay, based on what I'm seeing, I think this might be causing it.
But it's still a guess.
It is, definitely needs to be tested.
Okay, how do you test it?
That's where inference comes in,
Right.
connecting the dots between your observations and your hypothesis.
So if your guess is right, what else should be true?
Exactly, you're looking for those logical connections.
Got it. Building the case.
Right.
But what if those connections don't add up?
That's where evaluation comes in. You gotta be willing to challenge your own assumption.
Right, question yourself.
Exactly, be honest, be rigorous.
Okay.
You might need to design experiments, get more data, even talk to colleagues.
Make sure it holds up.
Right.
So it's about being objective, not about being right.
Absolutely, it's about finding the truth wherever it leads.
Okay, so you evaluated, then what?
Then you reach the conclusion stage. This is where you make a judgment call.
Based on the evidence.
Right. All that investigative work leads to this.
But for engineers, the work doesn't stop there, does it?
Not at all. Next is action. Taking steps to address the problem based on your conclusions.
Put it into practice.
Yeah, you find a bug, you fix it.
Right. Make those changes.
Exactly. Turn that reasoning into results.
Okay, so you've taken action. What's the last stage?
Last but not least,
But-
reflection.
I had a feeling this was coming. This is where you really learn, right?
It is. You look back at the whole process from the
Yeah.
start to finish.
Yeah.
Ask yourself, what worked? What could be better? What did I learn?
Experience is the best teacher, but only if you reflect.
Exactly. And for engineers, this is key for that continuous improvement.
Got it. Honing those skills.
Yeah, becoming a better problem solver.
Okay, I have to admit, 8 stages, that's a lot to remember.
It is.
Thankfully, Mata gives us a shortcut, the PURIA Framework.
Yes, PURI is a great way to simplify those 8 stages into 3 main phases.
Okay, good.
And who doesn't love a good acronym? Makes it stick.
I'm all about those acronyms. Break down PURIA for me.
Okay, so first up is PUH, perception, understanding, hypothesis.
Right, that first phase then.
It's all about gathering info, making sense of it, forming that initial explanation.
Laying the groundwork like a detective.
Exactly.
Got it.
Then we move to IAE, inference, evaluation, and action.
Okay.
This is where your reasoning takes shape.
You test that hunch, connect the dots,
Exactly.
and then take action based on what you find.
Precisely.
And finally, reflection.
Can't forget that.
You step back, analyze the journey.
Right.
What did you learn?
Exactly. What worked well? What could be better? It's all about continuous learning and improvement.
Every problem is a chance to grow. I like that.
It is. It's not just about finding solutions.
Right.
It's about evolving your approach, getting more effective with each challenge.
This is great stuff. We've covered so much.
We have, from daily habits to the PURIA framework, Mata's really giving us a holistic approach.
He is.
Yeah.
I'm excited to see how these principles work in QA and DevOps, those specific fields.
Yeah, that's a great point. They have their own unique challenges.
They do.
And we'll need to see how this reasoning applies to them.
Perfect. So let's start with QA. Paint me a picture. How does reasoning work for a QA engineer? What's their day-to-day like?
Okay, well, think of a QA engineer as a guardian of quality.
Okay.
That last line of defense before the software gets to the user.
High stakes.
Big time, they make sure everything works perfectly, meets the highest standards, seamless experience for the user.
They're like the gatekeepers.
Exactly, and structured reasoning is their superpower.
Right. Give me an example.
Okay, so let's say we've got a QA engineer testing a new feature for a mobile app.
Okay, walk me through it.
It all starts with perception, remember?
Right. The first stage.
They examine those specs, understand what the feature's supposed to do, gather all the documentation.
Laying the groundwork.
Exactly, getting a full picture.
Okay.
Then they move into understanding, analyzing the design, identifying any potential risks, thinking about different user scenarios.
Like a detective searching for clues.
Precisely. This helps them form their hypothesis about any issues that might pop up during testing.
So they're making educated guesses about where the bugs might be.
Yeah, using their expertise to guide their testing.
Okay, so it's targeted.
It is. And then with inference, they think through the implications of those guesses. Like, if they think a certain function is going to cause errors, what other parts of the app could be affected?
Thinking several steps ahead.
Exactly. That's the beauty of structured reasoning. It's proactive.
Got it.
All right. Next is where things get real. Evaluation.
Time to put those theories to the test.
They design and run test cases.
Okay.
See if it holds up under pressure.
Try and break it.
Exactly. They're looking for evidence to support or refute those assumptions.
Right.
This helps them reach a conclusion about the quality of the feature.
So pass or fail.
Sometimes it's not that simple. Sometimes the testing reveals areas for improvement.
Even if it technically works.
Right. It's not just about checking boxes.
So they're giving feedback to make it better.
Exactly. It's about creating a high-quality product.
Okay, what happens next?
That brings us to action. Based on their findings, they might file bug reports, suggest code changes, even advocate for design tweaks.
So they're part of the solution.
Exactly. They're using their insights to drive those improvements. And of course, we wrap up with reflection.
The final stage.
They analyze the whole testing process.
Okay.
Look for ways to do it better next time.
Always improving.
Exactly. That continuous improvement mindset, even in QA.
Makes sense. So those same principles apply to DevOps too.
They do. DevOps is all about bridging the gap between development and operations.
Right. I hear that term a lot.
It's about collaboration, automation, continuous improvement,
Okay.
breaking down those silos between teams,
Right.
so everyone's working together.
Got it. More agile.
Exactly.
So how does structured reasoning fit in?
Let's imagine our DevOps engineer has to automate a new software release.
Okay.
It's a complex process, lots of potential problems.
I bet. Lots of moving parts.
Exactly. But structured reasoning can help.
Okay.
Simplify it, reduce those errors.
All right. How so?
We start with perception again. They gather information about the current process.
Understand the current state?
Exactly. Identify bottlenecks, define those desired outcomes.
Doing their homework.
Right. Then they move to understanding, analyzing those dependencies, identifying risks, thinking about different strategies.
Weighing the options.
Precisely. And based on this, they form their hypothesis about the best way to automate.
A plan of attack, but based on analysis.
Exactly. Informed decisions.
Okay.
Then with inference, they think about the implications.
What will happen if they automate a certain step?
Right. Any unintended consequences?
Making sure it doesn't create new problems.
Exactly.
Ugh.
And once they've considered that, it's evaluation time.
Put it to the test.
They test those scripts, monitor the process, gather data.
So they don't just set it and forget it.
No, they're actively involved, making sure it's working.
Okay, good.
This leads to their conclusion about the automation strategy.
Hopefully it's a success.
Ideally, but even if it's not perfect, they learn valuable lessons.
Right.
And then, of course, action, they implement the process.
Okay.
Keep monitoring, making tweaks based on their observations.
Always optimizing.
Exactly. And finally, reflection. Of course.
They look back at the whole journey, the challenges, the wins, the lessons.
And use that to improve.
Exactly.
Always learning.
Always. That's what makes Mada's work so great. It's not just about tips. It's a mindset shift.
All right. A way of thinking.
Exactly. That can help anyone.
This has been so insightful. We've learned so much.
We have.
What's the most valuable takeaway for you?
For me, it's that structured reasoning is more than just steps. It's a way of thinking.
Right.
It's about being intentional, curious, always willing to learn and grow.
Not just for engineers.
Absolutely not.
I love that.
Yeah. Yeah, it's amazing how much we've already talked about.
I know, right?
From those basic habits to really diving into structured reasoning, the 8 stages, the PURIA Framework.
Yeah.
Mada is really giving us a complete approach to productivity.
He is, and I'm really interested to see how this all applies to, specific fields like QA and DevOps.
Oh, yeah. Good point.
I think it'll be really fascinating to see how structured reasoning works in those areas. Definitely, those disciplines have their own, specialized approaches, right?
Yeah.
So we got to see how reasoning fits in.
Okay, let's start with QA then, quality assurance.
Okay.
So give me a picture. How does structured reasoning actually work for a QA engineer? What does that look like day to day?
Well, think of a QA engineer as the guardian of quality.
Okay.
The last stop before that software gets to the user.
No pressure.
Right.
Yeah.
They're the ones making sure it works perfectly.
Yeah.
Meets the highest standards, it's a smooth experience for the user.
They're the gatekeepers.
Exactly. And structured reasoning, that's their secret weapon.
Okay. I like it. Give me an example.
All right. So let's say we've got a QA engineer testing a new feature for a mobile app.
Okay. Typical scenario.
Right. So it all starts with perception, like we talked about.
Right. Back to the beginning.
They look at the specs, understand what the feature should do, get all the documentation.
Laying the groundwork.
Exactly.
Okay.
And then they move to understanding, they're analyzing the design, spotting potential risks, brainstorming all the different ways a user might use the feature.
So they're anticipating problems.
Exactly, like a detective looking for clues.
Okay.
And this helps them form a hypothesis about what might go wrong during testing.
So they have an idea of where the bugs might be.
Yeah, based on their experience and knowledge of the app.
Okay. All right.
Then with inference, they think through, what if those guesses are right? What happens then?
Okay.
So let's say they think a certain function is buggy.
Yeah.
What else could that affect? How could those errors, spread?
That's thinking ahead.
Right. It's proactive. That's what's so cool about structured reasoning.
Got it. So then what?
Now it's time for evaluation, the real test.
Time to break things.
Right. They design test cases, try to push the software to its limits.
Through the ringer.
Exactly. And this helps them reach a conclusion about the quality.
So does it pass or fail?
Sometimes it's not that black and white. The testing might show areas that need work.
Even if it technically functions?
Right. It's not just about checking boxes. It's about making it great.
Feedback for improvement.
Exactly. They're helping to build a really good product.
Okay, so what happens after the conclusion?
Then comes action. Based on what they found, they might file those bug reports,
Okay.
suggest code changes, even say, hey, maybe the design needs tweaking.
So they're part of the solution, not just pointing fingers.
Exactly. They're using their knowledge to make it better.
I like it. Okay. And then what's last?
Last but not least, reflection. That critical step.
Right. They look back and see what they learned.
Yeah, analyze the whole process, figure out how to do it even better next time.
Always improving.
Always.
Makes sense. So this applies to DevOps too.
It does. DevOps is all about connecting development and operations.
Right. Making it all seamless.
Yeah, collaborating, automating, always improving.
Streamlining the whole process.
Exactly.
Okay. So how does structured reasoning fit in there?
Let's say a DevOps engineer needs to automate a software release.
Okay. Complex stuff.
Oh yeah, lots of things that can go wrong.
I bet.
But reasoning can help simplify it, reduce those errors.
Okay. I'm listening.
So we begin with perception. Just look before.
Right. Gather the information.
They got to understand the current process, where are the bottlenecks, what are the goals.
Getting a clear picture.
Exactly. Then it's understanding. They analyze those dependencies.
Okay.
Think about the risks, consider different strategies.
Lots of options.
Yeah. And based on all that, they form their hypothesis, the best way to automate.
So it's not just a random approach.
Nope. It's based on careful thought.
Right.
With inference, they think about the consequences, you know?
Like what happens if they automate a certain step?
Oh, right. Could it cause other problems? They got to think it through.
Anticipate those ripple effects.
Exactly.
Okay. That makes sense.
So once they've done that, it's evaluation time.
Time for testing.
Yeah, they test those scripts, monitor everything, gather data.
Make sure it's actually working.
Right. They don't just walk away.
Okay, good.
And all of that leads to their conclusion about the automation strategy.
Hopefully it all works.
You hope so, but even if there are hiccups, they learn from it.
Right. Always learning.
And then, of course, action, they put the process in place.
Okay.
Keep an eye on it, make adjustments as needed.
With continuous improvement.
And finally, reflection.
Gotta have that reflection.
Right. They look back at the whole journey, what worked, what didn't, what can they learn?
Always striving to do better.
Exactly. That's the key takeaway here.
Yeah, this has been fantastic. We've covered so much, from those daily habits to the power of structured reasoning.
It's been great.
It has. Mod has given us a lot to think about.
He has. It's not just about being more productive. It's about approaching any challenge in a smart way.
I love that. It's a way of thinking.
Exactly.
Well, this has been a truly fascinating deep dive.
It has.
I hope everyone listening is walking away with some great insights, you know,
Me too.
and a new appreciation for the power of structured reasoning. It really can make a difference.
It can in any field.
Absolutely. Well, thanks for joining me on this journey into the world of engineering productivity.
It's been fun.
It has. Until next time, keep those minds sharp and those problem-solving skills honed.